Fibonacci sequence. So let's start with patterns. Patterns are basically in-order chaos. They repeated designs, shapes, or numbers that we see all around us. One of the most famous patterns in math is Fibonacci sequence. So the sequence goes like this: 1, 1, 2, 3, 5, 8, 13, and 21, and etc. And it keeps going. The rule is simple. Every number is the sum of the two numbers before it. So 3 plus 5 equals 8, 5 plus 8 equals 13, and so on. But here what's crazy. This isn't just math. On paper, Fibonacci shows up everywhere in nature. Count the seeds in sunflower and you get Fibonacci numbers. Look at the spiral of nautilus shells, pine cones, and even in the way leaves grow on a stem. They all follow this pattern. So galaxies and hurricane spiral in the same way too. When you take the ratio of two consecutive Fibonacci numbers, like 21 divided by 13, you get about 1.618. That's the number is called golden ratio or P. And humans find that ratio super pleasing to look at. That's why architects, artists, and designers use it on purpose. The Parthenon in Greece, the Mona Lisa, Apple's logo, even the layout of websites, they all use the golden ratio to look balanced, natural, and beautiful. So math patterns aren't just textbooks. They're literally how nature designs things and how we make things look good. So next time you see a spiral or something that just looks right, that's Fibonacci and golden ratio at work. Logic and propositions. So let's talk about logic. In math, logic is all about true or false statements. We call those propositions. So there's no in between. Example: dogs have 4 legs, which is true. So the Philippines is in Europe, which is false. So if a condition is true, do this, else do that. So let me give you some real life examples of logic. So in Shopee, in Lazada, if your voucher code is valid, then apply 100% off, else show invalid code. So let me give you some other example. So in online class or Google Meet, if your mic is on, makikita niyo yung ganyan. So if your mic is off, nakalagay ay muted. So without logic, nothing would know what to do next. So no payments, no game moves, no doors opening. And we use logic to studying. It helps us think clearly, spot mistakes, and make better decisions. So that's why it's used in coding, AI, law, and even arguments.
A ratio and proportion. A ratio is a comparison of two quantities using division. It tells us how much of one quantity there is compared to another. Ratios can be written in 3 ways: using a colon such as 2/3, using the word 2 as 2 to 3rd, or as a fraction 2/3. For example, if there are 12 boys and 18 girls in a class, the ratio of boys to girls is 12 to 18, which simplifies to 2/3. While a proportion, on the other hand, is an equation that states two ratios are equal. For example, 2/4 equals to 4/8, because both ratios represent the same value. Proportions also help us find unknown values by using cross multiplication. So the question is, how do ratio and proportion apply in our everyday life? We use them in cooking by adjusting the amount of ingredients while keeping the same taste. If a recipe serves 2 people but you need to serve 4, you simply double all the ingredients while maintaining the same proportion. We also use ratios when shopping to compare prices and determine which product offers the best value for money. For example, comparing the price per kilogram or per liter help us make smarter buying decisions. In conclusion, ratio and proportion are more than just mathematical concepts we learn in school. They help us solve problems, make accurate calculation, and make better decisions in our daily lives. By understanding these concepts, we can apply mathematics in practical situations every day. Now, let's discuss the algebra. Algebra is a branch of mathematics that uses numbers, letters, and symbols to represent unknown values and solve problems. Instead of working only with numbers, algebra allows us to use the variables such as x or y to stand for values we do not yet know. For example, if we have the equation x plus 8 is equals to 15, we subtract 8 from both sides to find the value of x, which is 7. This simple example shows how algebra helps us find unknown values and solve equations. Algebra is not only used in the classroom, it is also part of our daily lives. When shopping, algebra helps us calculate discounts, taxes, and the total cost of items. For example, if a shirt costs 800 pesos and is on a 25% discount, algebra can help you determine how much you will pay. In budgeting, algebra helps us manage our money by calculating expenses, savings, and monthly income. It allows us to plan our finances wisely. Algebra is also useful when traveling. It helps us estimate the time we need to reach a destination based on distance and speed. This is why navigation apps can predict your arrival time. In construction, engineering, and architecture, algebra is used to calculate measurements, design buildings, and ensure structures are safe and accurate. Even in sports, algebra helps calculate scores, average, and player statistics, allowing coaches and athletes to evaluate performance and improve strategies. In conclusion, algebra is more than just solving equations. It is a valuable tool to help us solve everyday problems, make informed decisions, and understand the world around us. By learning algebra, we develop critical thinking and problem-solving skills that are useful in school, at work, and in daily life.
Geometry. Geometry is the branch of mathematics that studies the sizes, shapes, positions, angles, and dimensions of things. It helps us understand and describe the physical space around us. These are the core concepts of geometry. The points, lines, and planes are the fundamental building blocks of all shapes. Next is two-dimensional shapes, or 2D, are the flat shapes with length and width. For examples are triangles, circles, and rectangles. Next is three-dimensional shapes, or 3D, which are the solid objects with depth. For examples are cube, spheres, and cylinders. Next is angles and symmetry. These are how lines meet and how shapes mirror each other. Next is perimeter area and volume. These are the formulas used to measure the boundaries, flat surfaces, or carrying capacity of shapes. So how can we use geometry in our daily lives? You use geometry every morning when you pack your backpack for school. Your backpack has a specific three-dimensional volume and your supplies are various geometric shapes. Which has the rectangular prisms, your notebooks and textbooks, and cylinders, which is your water bottle and glue sticks, and smaller rectangular prisms, which is your pencil case.
All sat in classroom, look at a whiteboard full of formulas and thought and say, when am I When I'm ever going to use this in real life? We are usually taught that math is just about formulas and exams, but the truth is, math is actually the secret logic running the background of your daily routine. And let's look at two major examples, the geometry and calculus. Math is geometry. In school, it's all about the calculating the area of a triangle or memorizing the shapes, but in real world, geometry is how you master physical space. If you ever try to fit heavy gear, clothes, and shoes into a single sports bag, your brain was doing geometric optimization, arranging shapes to eliminate empty space. And if you play sports, you use geometry every single second. You are constantly calculating the trajectory of a ball, judging the angle of a bounce, or figuring out the fastest path to intercept an opponent. You see a complex math cafe. Remember, school teaches you the mechanics and the formulas, but life is where you use the logic. Math isn't just a subject on a chalkboard, it's a tool to help you navigate your world. And thank you. Then there's calculus. It sounds intimidating, but conceptually, it's just the math of motion and change. Think of this way, geometry is for things that stay still, but calculus is for things that move. Every time you look at a fitness tracker or smartwatch during a workout, you are looking at calculus in action. The tracker uses derivatives to measure your exact rate of change, like how fast your heart rates spike when you sprint, or how your running pace fluctuates minute by minute. It takes a constantly changing activity and turns into clean, useful data.
Good day everyone. Today I will talk about sets. A set is a group of collections of objects. The object inside a set are called elements. These can be numbers, letters, people, animal, or anything that belongs to the group. For example, the sets 1, 2, 3, and 4 is a set of numbers. The set apple, banana, and mango is a set of fruit. There are different kinds of sets. An empty set has no element. A finite set has limited numbers of elements. An infinite set has no end, like the counting numbers 1, 2, 3, and 4, and so on. We can also combine or compare sets. The union means putting two sets together. The intersections means finding the elements that are both in the sets. In real example, one student is who like apples and another sets of students who like mangoes. Some students may like both apples and mangoes. Those students belong to the intersection of two sets. If we list everyone who like either apples or mangoes, that is the union. Sets help us organize the group things in school and everyday life. Good day everyone! Today, I will talk about mathematical language. Mathematical language is the special language we use in math. It uses numbers, symbols, and words to explain ideas and solve problems. Some common math symbols are this, it means add, and this one means subtract. Also, this one means multiply. For this one, divide. And this one means equal. This one is greater than. And this one, a less than. For example, in 5 plus 3 equals 8. The plus sign means add. The equal sign means the answer is 8. Real life example. If you buy 2 notebooks and then buy 3 more notebooks, you can write it as 2 plus 3 equals 5. Another example is comparing ages. If Anna is 12 years old and Ben is 10 years old, we can write 12
Greater than 10 means Anna is older than Ben. We use mathematical language every day when we count money, tell time, measure ingredients while cooking, solve problem in school. Learning mathematical language help us understand math better and communicate our answer clearly. Mathematical language is the foundation of mathematics because it allows us to express ideas clearly, solve problems efficiently, and understand. Thank you!